In this video, I'm going to go through even more functions relating to differentiation. If you're comfortable with differentiation by now, this should be also quite easy. If you've passed the first video, this should be good as well. If you haven't watched the first video, you're still unsure, I wouldn't recommend starting with this one. So do pause the video throughout if you want to attempt some of the questions to go through them, and then we'll go through the solutions. So a couple more things I want to differentiate, and it's with terms, with the functions that have more than one term. So let's go quite deep now. Let's say if I have y equals to 1 over 3 x to the power of 9 plus x to the power of 5 plus x squared plus 9. Well, remember, you're going to still use the differentiation rule, and you're going to apply it on every term. It doesn't matter, as long as there's a plus or a minus between them, you still apply the rule. So first rule is we take the power and we multiply it by the coefficient. Now this is a fraction, but it's fine, doesn't matter. We do 9 times 1 over 3, that's the rule. And then x, instead of a power of a 9, we reduce it by 1, so it's going to be a power of 8. And then the next one, remember that all of these have a coefficient, so both of them have a coefficient of 1. So 5 times 1 will be 5. And then the power of 5 will be reduced by 1, so it's going to be 4. Similarly for the second one, 2 times 1 will be 2, and then the power of x will be reduced from 2 to a 1. And then remember that the derivative of a constant is always 0, so we don't need to write the derivative. You can write plus 0, but it's redundant, we just don't write it there. So we can simplify the expressions now. 9 times 1 over 3 is the same as taking a third of 9, or just saying 9 divided by 3, because 9 times 1 will be 9 over 3. Which simplifies to a 3. So that's 3 x to the power of 8 plus 5 x to the power of 4 plus 2x. I don't need to write the power of 1 there. So that's you differentiating the function. So again, remember that the questions could say find dy by dx. It could say find y prime. It could say differentiate, find the derivative, find the gradient function, and so on. Let's say you had more of the questions with fractions or with negative powers. So if you had y equals to negative 1 over x squared minus 3 over x, and then say plus 2x cubed minus 3x. So quite a lot of functions. The point of me making it quite complicated is just to show you it's all the same thing. Actually, before we differentiate, remember that whenever you have a variable in the denominator, you always want to fix what the function looks like so that the variable in the denominator ends up being in the numerator. And that way we can use the rules for differentiation. So if I bring this up and bring this up, and we're only bringing the numbers, we're not swapping the fraction, we are not changing the signs or anything, we're just taking the variable, even if there's a number here, say 2, we're not moving the 2. We're only moving the variable, the letter. So when you move it up, we're actually not moving it up, but I'm not going to get to the technicalities of the laws of indices. When you're moving it up, you change the sign to a negative. So I'm going to keep this as it is, the negative 1. And when I bring this up, it's going to be x to the power of negative 2. And then similarly here, I'm going to keep the negative 3, but when I bring this up, it's going to be x to the power of negative 1, because this has a power of 1. And this stays the same, nothing changes here, I don't need to change them. Now, I have lovely x's all in the numerator. I'm just going to simplify this further. I don't need to write the negative 1 here. So it's just a negative x to the power of negative 2. This will be negative 3 x to the power of negative 1, and so on. I'm going to take this away again, just because it's going to be repetitive. Now, if I'm going to do the derivative, You take the power, you multiply by the coefficient. So we have negative 2 times a negative 1. Be very careful with negatives here. And then we have x to the power of, well, we have the power negative 2, but then we need to take away 1. So we'll deal with this later on. Then we do the same thing for the other one. We have a negative 3 being multiplied by a negative 1. So that's another value we have to deal with. And then we have all of this is being multiplied by x to the power of negative 1, and we're taking away, so that's a negative 1, and we're taking away 1. Then we have a plus, well, 3 times 2 is 6, and then x to the power of 3 ends up being x to the power of 2. And this, remember that if we ever have a variable with a coefficient of 1, a variable with a power of 1, the derivative is always the coefficient. So in this case, it's negative 3. And then we simplify what we have. So negative 2 times negative 1 will be positive 2. Negative 2 minus 1 will be negative 3. And then negative 3 times negative 1 will be a positive 3. Negative 1 minus negative 1 will be negative 2, and the rest is already simplified. Then we can fix it if you want. So instead of having a negative power, I can bring it down and then change the power to a positive. And again, do the same thing here. So I'm just bringing it down to a fraction because it's still a fraction there. And I'm going to bring it down, and the power is going to end up being positive, or the signs is going to change. So that's you finding the derivative. Now there are other functions I briefly want to go through, which are functions which do not use y and x, but they are still differentiable. You can still apply differentiation to them. It's just that differentiation is useful application in real life situations, and you might end up with a function that uses variables relating to speed, to distance, to volume, and so you don't necessarily use y and x. So you'll be using different letters. So for example, if I have w equals to a to the power of 7. Well, this is me just saying it's a function of w where a to the power of 7, and if I want to find the derivative, remember that we always had y and then something in x here, so the derivative always was derivative of y, derivative of x, so dy by dx. This time it's going to be dw over dA. So if they say find dw over dA, well, it just means find the derivative of this function. And you're going to apply the same rule, so this will be 7a to the power of 8. Let's try another one. If it says k is equal to negative 2 over 3w to the power of 6, well, this will be the function itself, whatever is the subject, dk over dw. I could also say, well, find k prime. Remember, you're allowed to do that. And so this will be 6 times this. So it's 6 multiplied by the coefficient, which is negative 2 over 3. Be careful about negatives. And then you have w to the power, well, instead of 6, it's going to be 5. And this you can simplify without using a calculator. This is 6 over 1. And this cancels out with the 3. So 6 divided by 3 is 2. 3 divided by 3 is 1. And so you end up with 2 times negative 2, which is negative 4. 1 times 1, which is 1. You don't need to write that. And you have your w to the power of 5. You can also use your calculator for this. So these are the two main things I wanted to focus on. I'll give you one extra question. You can try and solve it, and then I'm going to pause the video. You can pause the video, and then I'm going to show you the solution. So the question is find dy by d m. when y is equal to 11m to the power of 4 plus 12d to the power of 3 plus 9d to the power of 2 plus 14d plus 15. So do pause the video. All I'm going to do in the next few seconds is write down the solution. So dy by dm, doing each one separately, this will be 4 times 11, which is 44, and then m will be to the power of 3. Next I have 3 times 12, which will be 36, and then d to the power of 2. And then I have 2 times 9, which is 18, and then d to the power of 1, but I don't write it. And then I have 14d, and remember this is to the power of 1. So if it's to the power of 1, all you have to do is take the coefficient, which is a positive 14. And the derivative of a constant is always 0, so I don't need to write it down. And that's it. This is how you derive more complex expressions.